Again, so we're going to be looking at evaluating expressions with, excuse me, involving square roots. So we're going to be looking more at adding and subtracting different terms that have roots with them. All right, so write down this example. So remember that 5 outside of that square root, when you pull something out, you're going to end up multiplying it. Okay, so you're not going to add what's outside. So pretend there's parentheses around that square root. Okay, and we're going to pull it out. So we're going to say 5 and then square root of 36. Is 36 a perfect square? Is it? Yes. What's the square? 6. So we're actually going to pull out 5, right, times 6. And then we're going to add the 7 because we have to follow PEMDAS. We take care of our radicals and exponents first and then our parentheses. So what's my next step to do then? Multiply, right? I'm going to multiply 5 times 6. That gives me 30. And then add the 7. So what is my answer to 5 radical 36 plus 7? 37. Pretty easy, right? So it's just making sure that you take care, you use that card that I gave you, that you understand the radicals or what is a perfect square, and then that you're multiplying on the outside. Right, Justin? All right, here's the next example. Go ahead and write it down, and then go ahead and see if you can figure out. Is 81 a perfect square? Is 81 a perfect square, yes or no?
Oh, no.
It's not?
Yes, it is.
It is. All right, so go ahead and try this on your own. I'm going to give you about 2 minutes. All right, so we said that 81 is a perfect square, right? But first I'm going to take out my 2. And I'm going to multiply it by that perfect square, which is what? 9. And then I'm going to bring down my minus 21. So when I first multiply my 2 times 9, I'm going to get 18 minus 21. So I'm going to have a negative answer, right? Because 21 is going to be my bigger number. And my answer is going to be, how many of you guys got that without me? Excellent. It's a start. Oh, because you forgot this. Remember, use that. If you use column method, you would have seen that that ends up on the negative side. So make sure you use that column method. It's super helpful for you guys. All right, new example. This time it's a little trickier. I want you to just copy it and then put your pencils down because you got to pay attention to me. All right, so this time I have a square root squared. Okay, when I have a square root that is squared, okay, so this is square root squared, these guys cancel each other out. So I'm going to cancel that and I'm going to cancel that. Okay. They kind of like wipe each other. It's like a positive and a negative. It becomes 0, right? They're the same thing. It just wipes each other out. It's like a hurricane. Comes through and takes it all out. Okay? So I can still solve this now by rewriting it as 15 minus 4. Right? Because once I cancel out my radical and my exponent, it just, all I'm left with is a 4. So what is 15 minus 4? Right? Oops, I went too far. So go ahead, I don't know. Go ahead and copy this one down and see if you guys can solve this one out. Take about 3 minutes to solve it. All right, Frank, so what happens to that radical 81, that radical in that square? what happens? It eliminates, right? So that radical eliminates and that square eliminates. They eliminate each other. So what's my new equation there? 81 minus 5. And my easy answer is what? What is it? How do we get 36? Look at my answer. What's 81 minus 5? What's that minus? What's that sign right there? Why? Why would I flip it? Why would I flip anything? What tells me to flip it? It says 81 minus 5. I didn't move anything over. I didn't divide by anything. I just brought it down. So I brought it down as a minus 5. Okay, there was nothing else involved in there. I didn't switch it.
Yeah, because it was 15 minus the radical and the 4. The radical.
Oh, but I didn't. No, I didn't. Oh, okay. So the example is different. So you're saying
Yeah.
it was 15 minus radical 4 squared. It doesn't matter because when you eliminate those radicals, it stays. It just becomes a whole number. So it doesn't matter what side. Side doesn't matter. You keep the sign of that particular number. The negative, the 4 ended up being negative because there was a minus sign in front of it. If you multiply 4 times a negative 1, what do you get? Negative 4. Okay? Yeah. All right. Huh? I'll show you right now. I'll show you when we do an example on our homework. Okay? Okay. So be careful here because we have to take care of that fraction first. Right? So I'm going to go ahead and I'm going to say, well, that 25 is a perfect square, and so is that 121, right? So I'm going to bring down my 8. I'm going to bring down my negative 11. And then in parentheses, because I am multiplying, right? What is the square root of 25? 5. You guys should have it on your note card. What is the square root of 121? 11. So my fraction is going to be in parentheses 5 over 11.
Why is it 1 5?
Why is what the what gone?
I'll get how you got that fraction.
Oh.
Well, kids, yesterday you made a note card. Do you remember that note card? On that note card, it said that 5 squared is what? What is 5 squared? What's 5 times 5? 25, right?
Yeah.
So the top part says 25, right? What is the square root of 25 then? What number times itself is 25? 5. That's how I got that. And 121 is the square root of 11.
Oh, okay.
Or 11 squared. Okay? So I'm going to go ahead. No, sorry, I pushed that button. So I'm going to eliminate, right? Because if I wrote 11 over 1, my 11s are going to cross cancel, correct? So then I have 5 over 1, which is 5. So my new equation is 8 minus what? 5. So what's my answer? Wait, what? What's my answer? 3. Right? 3 becomes my answer. Make sense? All right, here's a new example. This one looks really crazy, but it's not. All we're going to do is solve what's inside the parentheses first. Okay? And then multiply it by 3. So is 125 a perfect square? It's not. But I can divide 125 by 5, right? So what's 125 divided by 5? What's 125 divided by 5? 125 divided by 5. What is it, Frank? It is 25. Okay, so my 25 then is still underneath that radical. So I'm going to bring down my 3 and my parentheses. But I know that 125 divided by 5 is 25. So I'm going to write it up as a radical inside my parentheses. All I did was divide that fraction to get 25, still underneath that radical sign. And I'm going to bring down the rest of my equation inside that parentheses, which is minus 8. But I still have to take care of what's inside that parentheses. Is 25 a perfect square? What is the square root of 25? 5. So I can rewrite my equation as 3, and then in my parentheses, 5 minus 8. Right? So now I still need to solve what's inside the parentheses. What is 5 minus 8? What is it? It's negative 3, right? So I'm going to write it up as 3 times a negative 3. And what is 3 times a negative 3? So my answer then is negative 9. Understand? Easy peasy lemon squeezy? All right. I'm going to stop the notes here and I'm going to pass out your assignment, or somebody's going to pass out your assignment. And then we're going to do some examples on the homework. Just a couple of refreshers. What do we know about a perfect square? What are the sides of a square? They are what? If I have a square, what do I know about my sides? They're the same, right? A rectangle is different, correct? We talked about that yesterday, didn't we? Okay, so what do I know about the sides of this square? They're going to be the same. So what is the square of 100? Okay, so if I take the square root of 100, my sides are going to be, okay? So my side is 10, right? Same thing for here. Take the square root of 49. So all you're doing is taking the square, finding your answer, and then writing down that letter down here, okay? So T is 10, so I'm going to find 10, and I'm going to write a T there, okay? Same thing for this section here. Same, and then we go to the bottom half, and we're writing it in on the lower section. Okay, so here I want to do a couple examples. So here we go. So if I'm taking radical 2 times radical 2, I end up doing this, right? Radical 2 squared, correct? So what happens when I square a radical? What happens? It's like a hurricane, and they get what? They get wiped out. So what is my answer? 2. Okay. Now here, be careful, right? Does these cancel? Are they going to cancel? Do I need to follow PEMDAS and do my equation first, right? I have to do the exponents first, right? So what is 12 squared? What is 12 squared? 12 squared. You guys should have it on your note card. Where's your note card? It's 144. What is 5 squared? What is 5 squared? What is 24 plus 25 plus 144? 169, right? So that gives me 169. Is 169 a perfect square? Yes. What is the square root of 169? Which equals 13. So let's look for 13 down here and then write the letter A. Okay, be careful when you have more than one underneath. Okay, if it's underneath the hat, they're not going to cancel. They only eliminate when I'm taking that radical and squaring it. How about S? Would they eliminate there?
Yeah.
Yes, they would. But they don't eliminate here. Here I have to do the exponents first and then find my answer. Question? Let's look at this one because it has a decimal. Do we know the square root of 64?
Yeah, that's right.
It's going to equal 8, right? So this might also be something like 8, right? What we need to do when we have a decimal is we're going to divide. I have 2 decimal places, right? I'm going to divide 2 by 2. What do I get? 1. So when I write my answer, I'm going to have 1 decimal place. If there was 4 decimal places, I would have 2 decimal places. It would be 0.08. So for example, let's say it said 0064. How many decimal places? 4, right? Divided by 2, what does that give me? 2. So my answer is going to be 0.8. 2 decimal places. Yes.
What about 3?
It won't.
Okay.
I would never do that to you. Got it? Understand? All right, you're on your own.